Actually, let me save this here and then get a new page.
My name is DIFC.
My program, I'll show you now. Hang on, hw2.png. What I did for hard, yeah. I wrote some little program. So when I type the word DIFC, it changes the size of the screen. It starts recording the screen. It turns the microphone. Yeah, I made my own command. Well, of course I did. There's no command called DIFC. So when I type in DIFC, it turns the microphone on, it turns the volume on, it records the screen, it changes the size of the screen, and that's it all there, and saves it. Yeah? It is nice. Because what used to happen was I'd forget to turn the microphone on or something. So if I put everything I need to do in one command, I just type DIFC and then it starts recording. Okay. So we are lesson 5 now. Okay, so now we are going to start moving into, more real problems. So far we've just been doing basic knowledge, skills, problems. We haven't really been doing physics problems yet. We're just practicing basic skills which you'll need for all your problems. Okay, so what we're going to look at now, we're looking at some graphs. So we're looking at velocity time graphs. I sometimes may call them time velocity graphs because this is how it was taught to me in school, but I think nowadays the correct way is to call them velocity time. But you may hear me say time velocity. Okay, velocity time graphs. Okay, I can go on. You have the title? Yeah. So really, we're going to talk a little bit about, in more detail about motion, velocity, time, distance, displacement, and so on. Okay. I think a little bit of a diagram here might help things too. If I say one dimension, I mean like this. And if I say 2 dimension, I mean this. So that's what I mean, 1 dimension, 2 dimension. Now, this is the same word we had in our first lesson, dimensions and units. So it is the same word, okay? 1 dimension is this, and 2 dimensions is this. So how many dimensions do you think you need to have a vector? If you want a vector, do you need 1 or do you need 2? Or 1 or 2? What do you think? Or both? You think both, yeah? Yeah, we think we need 2 because we want to draw the arrow. But in fact, 1 is enough. In 1 dimension, if you have a positive number, it means you point to the right. And if you have a negative number, you point to the left. Like east and west. But it's still a vector. It's still a vector, even though it's just 1 number. Okay? Again, right is positive, left is negative. And vertically, up is positive and down is negative. Just like in math class, positive, negative, negative. Yeah? Okay. So my example is, if x is 1 meter, that means 1 meter to the right. And if x equals minus 1 meter, that means 1 meter to the left. You don't need to write this down because you should know this from math class. Okay. Right, so now we have a definition, so you do need to write this down. Acceleration, so this is a new word. Yep. So first thing you need to know about acceleration is acceleration is a vector. So it is a vector firstly, that's important. And it is the rate of change of velocity per time. So that's it in words, and then I'll give it to you as a formula. Okay? So as a formula, that means A is the change in the velocity divided by the time.
This is the formula for?
So this is the formula for acceleration.
P minus U.
Yeah, we'll get into that in a moment. But just as a basic idea, acceleration is the change in velocity. So for example, if you are in a car and the car is going at 100 kilometers per hour and then the speed increases to 120 kilometers per hour, we say the car has accelerated. Accelerated means change the speed or change the velocity. So accelerate is a verb. It's a verb that means change the velocity. Okay? I'm telling you these English things to help your English. So maybe you want to write this down? Maybe? What's accelerate mean? No. She can tell me. Accelerate? So you weren't listening to me. So, yeah, go ahead. Yep.
It's velocity change.
Okay, good. Yeah, you were listening. So accelerate is the change in velocity per change in time. Okay.
What's the word?
What? What did you say?
No.
Did you say what's velocity?
No.
Okay, good.
No.
What were you asking? You can ask me. I don't mind.
I forget.
Okay, fine. That's okay. Look, this symbol here means change in velocity, and this symbol here means how much time I've taken. If you knew that, you don't need to write that down. You can just write change and change. But I think some people maybe have seen this delta symbol before. Yeah, you've seen this before, the symbol, yeah? Yeah, in the physics book, yeah. That'd be a good place to see it. Yep. Got it? No.
So what's the option?
Yeah, that was me kind of using, see, I try to keep my English simple, but every so often I make it a little bit more complicated because of the exam, you need to have a broad experience of different words. So elapsed just means really how much time, the amount. So it's just a fancy way of saying that, that's all. Okay, next slide. Yes? Yep. So we're going to use some new variables. So the first one is u. So when I write u, what I mean is the velocity at the beginning. Yeah, the initial velocity. You know all of these, yeah? I hope so, if you've done physics before. So some people have seen these letters before, so what's after U then? V. And what's V? Yeah, we use it for the final velocity, the velocity at the end. Yep. Well, we know what A is. What's A? Acceleration. And T, of course, is time. No surprise there. And then lastly is S, and S represents the displacement. That's the position. Okay. Even if you know them, just at least write down the ATS and one or two words beside them. Huh? You don't want your voice recorded? Don't be shy. How many people do you think are going to watch this? Maybe like 2. And you were probably one of the 2. Tell me when you're ready. I think I got more down here. No. Yeah. Ready? Mm-hmm. Yes? No. I still see people writing. Yes? Yeah. You don't need to take a picture because the video is going to go there tonight. Yeah. Okay, so look, let's explain with an example. Usain Bolt. So the U here is 0. Why is the U 0 meters per second? So in this example here, the U is 0. Why? Yeah? Wait, let her try and then you can. Yeah, go on. You? Yeah, why is it 0?
Because to stop. And
yeah.
he don't have the speed to go straight. I don't know.
Okay. U, what is U firstly? The velocity at the beginning.
Yeah.
Yeah? Yeah?
Because he's not picking me up,
Oh yeah, but I don't have a video, so it's the whole race I'm trying to get you thinking about here. So at the beginning of the race, the U is 0, because everybody starts at left. Yeah? Then, for this race here, maybe somebody knows this, the V. What might the V be?
0.
I know, because look at him, when he gets to the end, he's not 0. He's still running. So what's the V? Roughly. You think you know?
No, the number?
Yeah, if you got a rough idea.
Maybe 15
meters per second, please. Does anybody know for him? I think for him, the V is maybe about 14 meters per second at the end.
Maybe.
I think it's something like this. So the U is 0 and the V is 14. Then everybody should know this. What's the T?
9, 7?
Not quite 9, 9.6 or something, isn't it? Second, good. What's the S? 100 meters. And the A? We don't know, but it is acceleration. And we could calculate it. Yeah. But anyway, I use this example so you can understand the U, the V, the A, the T, and the S. The A is a big number because he started at 0 and he finished at 14. So his speed changed a lot. Okay. So please remember this. I don't want you to write this because first I want you to listen. So really, really, really remember this. Velocity can be positive or negative. So because it's a vector, it can be positive or negative. But speed is only positive. Okay? Displacement can be positive or negative because it's a position. So like +1 or -1. But distance can only be positive. Do not confuse speed and velocity, please don't, or distance and displacement. For most problems they are the same, mostly, but not always. Okay, so in my example with Usain Bolt, what is the distance he travelled? 100 meters. And how far away is he at the end from the start? He's also 100 meters. So in this example they're the same, but they're not always the same. And we'll see some examples where they're different. Okay? So you don't need to write this down, you just need to remember it. Okay? But I think we've said this enough times already. Okay, so what we can do is we can represent velocity and time on a graph. So here's an example. You can draw it in a moment, but I just want to go through each of the parts. So on the x-axis, can you see here is time, and on the y-axis is velocity. So in this example here, at the beginning the velocity is 0, and then it accelerates slowly. This means it gets faster and faster and faster, and then all of a sudden it gets very fast. So if we think about this as a car, this is what's happening. You put your foot down a little bit, and you go faster and faster. And then what happens here is you see somebody you don't like, and you put your foot down more, and then you try to hit them, so you go faster. Yeah? Then up here, this is when your speed stays the same. So this is when they're on top of the windscreen, or something like this. And then this here is when you put your foot on the brake. And what happens? You slow down, and then the person falls off. Okay? Then you stop. You stop here. So you're looking at the person on the ground. You're not moving. And then you decide, okay, time to get out of here. And you reverse. You go backwards. So then your velocity is negative. And then you continue going backwards at a constant speed. So what I'm trying to show you is you can represent what the story on this graph goes faster, stays the same, slows down, and then if it's negative, what does that mean? Going backwards. So everything about the story is on this graph. So now I'd like you to draw this, and if you can, try to write down these words as well, explaining each part of the journey. Steady speed, slows down, stops. Okay? Right, so am I still recording? Yes, I'm good. Okay. So let's have a look at our first question now. A car starts from rest. It slowly accelerates to 20 meters per second over 10 seconds. It then maintains its speed before suddenly decelerating to rest over 4 seconds. Draw the graph. So maybe what I can do is, because there's lots of words here, maybe I can have both open at the same time. That might be a bit messy. Actually, yeah, that might be okay. Does Adobe let you draw on the page? Is there an option to do that?
In which case?
It doesn't matter, I'll just squish it in underneath. So it says here, the car, well, let me first draw the X and the Y. So this one here is time, and this one here is velocity. And the unit is meters per second, and the unit here is seconds. So let's say this is 10, and this is 20, and this is 2, and this is 4. So it starts from rest. It slowly, it goes up to 10, so I need more than 2 and 4. So we'll say 5, 10, 15, 20. Okay. So it starts at rest and then slowly accelerates to 20 meters per second over 10 seconds. So it slowly goes up to 20 after 10 seconds. It then keeps the speed and then it then maintains the speed before suddenly decelerating to rest over a time of 4 seconds. Sorry, I should have said how long it kept the speed for. So let's say it keeps the speed for 5 more seconds and then suddenly comes to rest over 4 more seconds. So I'm going to draw it again, but a bit bigger. Okay. Ten, 5, 15, 20, and this is in seconds, and then it goes up to 20 and 10, and this is in meters per second. So it goes 0 up to 20, which is here. And then I didn't say it in the question, I'm sorry, but I meant to type in, it keeps this speed for 5 seconds, and then it comes to rest in 4 seconds. So this finishes at 19, because I said this is 4 seconds, and in the question I said this is 10 seconds.
You can find the distance by graph too.
Oh yeah, we're not doing that yet, we're just drawing the graph, okay? Can I go on? Yeah, let's go on. Now, you only need to draw the first triangle. You learn about this triangle in middle school. I'm sure you've seen it in middle school. So if you want distance, you say distance is speed multiplied time. And likewise, if you want time, you say distance over speed. And if you want speed, you say that's distance over time. So these 3 formulas, they're in one triangle. If you've seen this in middle school, don't bother to write it down. But if you want to write it down, you just need to draw the first triangle, distance, speed, time. How many people have seen this before? You've seen it? Yeah.
It's called Dad's triangle.
We call it Dad's silly triangle here because it's DST. Dad's silly triangle. Yeah. That's what we call it here. Dad's triangle only works when the velocity is not changing. So you can only use this triangle if there's no acceleration. So I'll say that again. This formula you learned in middle school only works when there is no acceleration. That is, the speed and direction stay the same. Yeah, so you can only use this when there is 0 acceleration. The speed does not change. Okay. So what do we do if the speed does change? What do we do if the speed goes from U to V? Okay. So it takes so I think maybe we'll do an example. Yeah. So I think we'll just do this example in our head because it's quite quick. I mean, you don't need to write it down. Look up. A boy walks 2 kilometers to school every morning and it takes him 30 minutes. What is his walking speed? Come on. Yeah, no, yes, go on, yes. What's the answer?
Wait.
No, you're about to say it, what is it?
I forget. Wait.
Oh, come on, physics students, I thought we could do this in our head. 4 kilometers per hour. No. What speed is distance over time? 30 minutes is half an hour. Yes, this is important. Alright, never mind. Anyway, you may be thinking that the velocity time graph is only good for giving you velocity and time. This is true, however, it can tell us much, much more. So let's have a look. Okay, so this is time, and we used seconds. And then this is velocity, and we use meters per second. Okay, so if you think about it like this, let's say this is 0 and this is t. What is this velocity at the start? What letter is that? No, forget about my example, yeah. Just in general, what letter is this at the start? It's u, the velocity at the beginning. And then this increases. So what's this letter at the end? V. Now what's this here? T. Sorry, T, yes. The time. Yeah. Now look at this. What unit is this here? This is meters per second unit, isn't it? And what unit is this here? Seconds. So if I calculate the area here, what unit is this area in? It's in meters seconds times seconds. No? Correct, meters. So in fact, the area in the graph represents S. So if you draw the graph and if you calculate this here, it's the S. Now let me give you a simple example, a very, very simple example. So here is 1 hour. And here is a boy walking at 5 kilometers per hour. Let's make it 2 hours. So if you walk for 2 hours at 5 kilometers per hour, how far have you traveled? 10. Now if I draw the graph, what's the area here? 5 multiplied 2 is 10 kilometers. So the area is the S. The distance in this case. Okay? Now, look at this. Here is the point T and V. And then this point here is, what is it? 0, U. In maths class we learned the formula for the slope, didn't we?
Yeah.
It's, what would it be here? B minus U over T minus C. But V minus U is the change in the velocity. So that is delta V. And then T is the time. So that is the A. In other words, the slope here of the line is equal to the acceleration. So the point I'm making is that in fact all of your information is on this one graph, which is why it is so important.
John, did you get the area?
How did I get the area? I didn't really get it. I'm just saying the area is the distance traveled. So if you calculate the area, it will equal the distance traveled.
Okay.
Yep. Okay, I can continue back with the slides. So to summarize, A is the height at the start, V is the height at the end, A is the slope, T is how big the base is, and then what's the area? That's the S. So the graph has all the information on it, UVATS. So here's our first example. In this example here, at the beginning it starts at rest. Then we increase the speed, and then what happens in the middle? The speed stays the same, and then it slows down. So the graph would look like this. It starts at rest, it goes up, it goes across, and it goes down.
Not till the end.
Huh?
Not till the end.
And it doesn't actually come to rest at the end. Yeah. So I want to draw this. Okay, so first just write this data down, this table here. And while you're writing that down, my graphing program can be loading. Okay. So for now, just try and write the numbers down. That's what I want first, and then we'll make the graph. Okay, so let's have a look at the graph here. Okay, so the first one is time. So what's the time? It goes to 0, 1, oh sorry, 0, no, 0 please, thank you. 0 plus 1 plus this one. Up to 10 seconds, is it? 10 seconds? Yep. Okay, and then here is the velocity. This is meters per second, and then the time here is seconds. Okay, what's it? 0, 5, 10, 15, 20, 20, 5, 5, 5. Okay, so let's graph this. You know how to put this in a graph. I mean, you're not children. Insert, mostly. Insert chart. So in the exam they'll want you to draw this on graph paper, but I can't really do that on the board, of course. So let me just... okay, so title is My First Graph. Okay, the x-axis is time in seconds, and the y-axis is velocity in meters per second. Oh, it's beautiful. Yeah. So this is what the graph looks like. So now what I want you to do for me, we can do it together. We want to use the graph to calculate the distance, the acceleration, and the deceleration. Okay, so firstly, how can you calculate the distance?
Find the area.
Find the area. So the first thing we want to do is see the distance, so we need the area. So if you look at this, you see that really we have a few shapes. First, our shape we first have is a triangle. You see that?
Yeah.
And then here we have a rectangle, and then here we have a triangle, and underneath this we have a rectangle. So there's a few different shapes put together here. What I want you to do now is calculate the area. So it might be helpful if you draw the shapes in, okay? So the first one is a triangle. What's the base of this triangle? How big is this triangle? Its base? 4. And what's the height?
20.
20. That's the first one. Half the base by the height is the area of a triangle. So, try this for me. Try to calculate the area of this shape. Do you know what to do? Okay, step 1, draw this. So, draw this first. Yeah. Did you draw? You need to draw this first. I'm trying to add from this. Did you have this drawn? Oh.
Did you find it again?
Yeah, but I'm trying to also find how I can draw on this. 10. I don't see it. Like it should look like this. No? Oh, hang on. No? Okay, that's okay.
You can write on the graph and make my pen.
You know what, maybe I'll just put it in paint. Good old paint. Did you draw it?
Yeah.
Yeah, okay. So what area did you get? Or did you not do that part yet? You got an area? Did you get the area? Yeah? What answer did you get?
No.
Oh, no answer? Okay.
7.5.
Hang on. Oh, come on. Come on, don't be a jerk. Copy. What
You can take a screenshot and...
Yeah, but this, I was trying to make this easy for me, but it's not doing it.
screenshot.
Yeah, that's what I'll have to do. Alright, let's calculate the area now. There we go. Right, so the first one is a triangle. Right, let me make this pen fatter maybe. Yeah. That's the business. Okay, how big is the base? 4, and the height? 20. So the formula for this area is half the base by the height. So a half of 4 is 2, and 2 times 20, 40. So this one here is 40. Okay.
Or control this.
That doesn't matter. Yeah. So look, the next one here is this rectangle. Okay. So how big is the base here? 1. And the height? 20. So what's this area? 20. I'll write it in. 20. Alright.
You can type it, but you can show.
This is already very ugly. I'm not even going to try to make it look nice anymore. So the next shape is this triangle here. Now how big is this base? 3. And what's this height? 15. A half of 3 times 15. 45 over 2? 22.5. 22.5. And the final shape is this rectangle here. So how big is this base? 5, and the height? 5. So the height here is 25.
Total is 107.
Yeah, so the total 40, 20, 22.5, 25,
107.5.
6 and 4, 107.5. So this car travelled 107.5 meters. Is how far it travelled. Look, it's ugly, but it's correct. Okay. Now the next question I asked was the acceleration. So you need to calculate the slope. So let's go back to our beautiful diagram. Okay. Right, so here is the acceleration. So what's the height? 20, and what's the base? 4. So the acceleration is 20 over 4, which is 5. So the acceleration is 5. What is the deceleration? The deceleration is this part. So what's the height of that triangle? So hang on, here the A is 5. And here, what's the height? 15. And the base? 3, is it? 1, 2, 3. And 15 divided by 3? 5. So the A here is minus 5 meters per second squared. So that's the acceleration and deceleration. So just remember here, I'll draw it here for you. If you have this, the A, you know it is y2 minus y1 over x2 minus x1, or in other words, it's this height, delta y, divided by this base, delta x.
I think there's acceleration.
There, that's how. Using this.
That's the D on delta x?
Yeah.
Delta t, sorry?
And delta t is the horizontal bit.
So you get acceleration of all the shape or only...
No, only for a certain part of the journey.
Certain part.
Yes, that's it, yeah. So the
And
acceleration...
then you like mix it together or what?
No, I mean, the question could be, what is the acceleration at the start? What is the acceleration at the end? What's the acceleration in the middle?
Oh, okay.
Yeah, so yeah, I get your point. The acceleration is not one thing for the whole question. It can be different at different parts. Are you okay?
When we say deceleration, it's not minus.
Yeah, the minus is in the word D. Yeah. Okay. Can I go back to the slides?
Yes.
Yeah. Alright, here's your questions to try. What I'd like you to do, I actually wanted to try and do at least one. There's lots of time. I want to check that you can do these. They are very important for the exam. Because, it's homework, but I'm expecting you to have one finished before you go home, which I want to check before you do.